So this video is going to be a bit of a summary of Chapter 5. We're going to take a look at the different forms, do a few problems together just to reiterate the most important points. Remember that the quadratic relations or the parabolas can be expressed in 3 different forms that we've studied so far. Let's get a bit of a thinner ink there. Let's get that pen. So we saw the standard form, which is y is equal to ax squared plus bx plus c. We also saw the factored form, where y is equal to a in the front here, open your brackets, x minus s, x minus r, where s and r can be your zeros. And then we also saw the vertex form, where y is equal to a, open brackets, x minus h squared plus k, where the h and k can help you find your vertex. So in the different forms you can find different things. For the standard form, you know that c is your y-intercept. For the factored form, we know that s and r can help you find your zeros. And for your vertex form, we know that the vertex can be found from your h and your k. We know the a values can tell you the direction of the parabola, whether it's opening from the top or the bottom. And so what I need you to get is that for any parabola, any given parabola, the a value is the same in all 3 forms. So if it's 2 here, it'll be 2 here, it'll be 2 here as well. Which basically means that you can use different forms to jump from one form to another. You can convert from standard to factored, then from factored to vertex, and the other way around. We've already seen that to go from factored or vertex form to standard form, you need to expand. We'll take a look at how to go from other forms, for example, from standard to vertex or from factored to vertex, using certain techniques. So depending on the information given, we can find the equation of a parabola using one of the 3 forms above. So if I give you some information and you don't know the equation, you can figure out the equation using that information. And so depending on the equation, you might be able to find the factored form first, or you might be able to find the vertex form first. And then you can convert to standard form after. So let's take a look at what that looks like. So if you're given the zeros and a point on the parabola, and a point on the parabola, then you can find the factored form. If you're given the vertex and a point on the parabola, then you can use or find the vertex form. And the idea is that you use your zeros and your vertex to set up an equation like the ones over here or over here. And then you're going to use a point to solve for a. So we'll do some examples of that. Once you have either your factored form or your vertex form, you can then expand and simplify to get to your standard form. So let's do a few examples together. Here we have some information provided to us. We have the a value provided to us and the vertex value provided to us. Because we have the a value and the vertex provided to us, we can figure out what the equations are going to be. We want to write the equation in standard form, but we don't have enough to do that right now, because we know that the standard form is ax squared plus bx plus c. We don't have b and c currently, but we do have enough information to write down our equation in its vertex form. So we can write y is equal to 3, which is the a. The vertex is 2, 9. So this is our h value over here. Remember, we switched to signs, so we have x minus 2 squared. And then this is our k value over here, plus 9. And so now what we can do is we can expand and simplify to get our standard form. So this is our first step. We wrote it in the vertex form because we had enough information to find the vertex form. Our second step is to expand and simplify. And so we're going to get y is equal to 3 times x minus 2 brackets x minus 2 because it's squared, and then plus 9. Ignore that dot there. And then we're going to have y is equal to 3 times, so x times x is x squared, minus 2x, and then minus 2x, so minus 4x, plus 4, and then plus 9. And then we can distribute our 3 within, and we get 3x squared minus 12x plus 12 plus 9. And then finally we can simplify by saying that the standard form is equal to 3x squared minus 12x plus 21. Just like that. Let's do another example together. So here we have a vertex at 1, 3, and we know the point 4, 5. So it's a bit different this time. We don't have the a value provided to us, but we do have the vertex provided to us, and we also have a point provided to us. So let's see what we can do there. We know we can start writing the vertex form. Y is equal to a. We don't know what it is yet. X, the h is 1, so minus 1. And then the k is 3, so plus 3. Don't forget to put the squared here. And what we have here is something interesting. We have a point given to us. We can actually use this point to find our a value and then plug that a value in after. We can simply sub the point into the equation. So our y is 5 is equal to a times our x is 4 minus 1 squared plus 3. So 5 is equal to a 3 squared plus 3. So 5 is equal to 3 squared is 9, so 9a plus 3. So what that means is that if we want to solve for 9a, we have to do inverse operations. So we send a 3 to the other side, and we get 5 minus 3 is equal to 9a. And so 2 is equal to 9a. Just do the work off to the side here. So 2 is equal to 9a. We divide by 9. Cross the 9 out there, so we get a is equal to 2 over 9. And so what that means is that our equation is going to be y is equal to 2 over 9 times x minus 1 squared plus 3. And so we used our vertex, we used a point, and we were able to find our vertex form. We're not quite done yet. We do need to expand in order to find the standard form. So you would go ahead and expand that. Y is equal to 2 over 9 times x minus 1 times x minus 1 plus 3 and then you would get y is equal to 2 over 9 times x squared minus 2x plus 1 plus 3. And then you can distribute everything in between, or within the brackets, so you would get y is equal to 2 over 9 x squared minus 4 over 9x plus 2 over 9 plus 3. And just to see what that 2 over 9 plus 3 is, I'm going to do the work up here. So 2 over 9 plus 3, I've put that in the same denominator, so that would be times 9, so 27 over 9. So that would be 2 plus 27 is 29 over 9. So we would have y is equal to 2 over 9 x squared minus 4 over 9 plus minus 4 over 9x plus 27 over 9. And that would be our standard form. So now we'll do example C together. You'll notice you'll have some different information provided to you here. This time you have zeros provided to you at a point. So if you have zeros provided to you, you know that you want to use your factored form first. So you're going to have y is equal to a. Our zeros are 2 and negative 6, so that means that we're going to have the opposite signs here. X minus 2, x plus 6. And we can use this point here to solve for a by plugging our points into the appropriate areas. So our y is negative 21 is equal to a, and our x is 1, so 1 minus 2, and then 1 plus 6. And we're going to get negative 21 is equal to a times negative 1 times 7. And so we're going to get negative 21 is equal to negative 7a. We can divide by negative 7. And so what we get is a is equal to 3. And so our factored form is going to be y is equal to 3 times x minus 2 times x plus 6. And then we can expand to get our standard form. So that means that y is going to be equal to 3 times, so x times x is x squared, then negative 2x plus 6x, so that's going to be plus 4x, and then minus 12 because of negative 2 times 6. And so now we distribute the 3 within, so y is going to be equal to 3x squared plus 12x minus 36. And so in each scenario that we did here, we had different information provided, and based on the information provided, we're able to come up with either a vertex or a factored form, and then afterwards we were able to solve for the a using the appropriate point provided and plugging those points, plugging the appropriate parts of that point into the y or the x based on what that point was. And then we expanded our either factored form or vertex form to find the standard form.